Hi guys. So today we're looking at nuclear fission. As you've noticed, this unit's going to look at a lot of different types of energy production. But one of the ones that we're really going to focus on, in fact, we're going to spend a whole day on it, is this one, is nuclear fission. The reason is because it's very contemporary. Well, I say contemporary, but in reality it's been around for 80 years. But it is something that's in the news quite often, and it's really a good idea that we understand what's going on when we talk about nuclear fission. What are the safety issues? What are the realities? And really be able to compare this to the other types of energy that maybe we're a little bit more familiar with, or at least will be when we finish this unit. Okay, so today that's exactly what we're going to look at. We're going to look at some of the details, energy transfers, things like that, but really focusing on nuclear fission and its details. So let's go check it out. So, nuclear fission has been around since the 1940s at least, possibly a little bit before that, but really has been developed significantly since then, since about the 1940s. Now, I want you to think about this. How many nuclear disasters do you know of that have happened since 1940? It's now 2020, so that's 80 years. How many nuclear disasters do you know of? All right. Well, you may remember Fukushima, which was recent, fairly recent, within the last 10 years or so. You may also recognize Chernobyl, which was the one in Russia, right? Which was a fairly big one that affected lots of people. And honestly, still, they are still trying to clean that one up a little bit. And then there's 3 Mile Island in New York, which maybe you haven't even heard of that one because it really wasn't that big a deal. But in the last 80 years, consider that there's only been three big problems, nuclear disasters with nuclear power. Okay? Now, I want to look at these. Consider first Chernobyl. Okay? This was Chernobyl. Yes, it was a meltdown. Yes, it made a mess. Yes, it was fairly nasty. Okay, there were approximately 125 people who died in the actual nuclear disaster. Okay, approximately 4,000 were eventually affected. This is people that were affected by fallout, things like that. It led to, scientists guess, 0.01% of cancers worldwide. Okay, so considering all the people that already get cancer, it only led to about a 0.1% increase of cancers worldwide. Okay, now you say, yeah, but what about the nuclear fallout all over the world? Well, the global exposure was equal to about 21 days of normal background radiation, which, I mean, most people don't realize this, but you're getting radioactive stuff every single day of your life. Okay, all the materials that your house are built out of, the ground, all of those things are actually have particles that decay from one type of particle to another. And the global exposure from Chernobyl, which was debatably the largest nuclear disaster of all time, was 21 days of normal background radiation. So not a huge thing. Yes, it did have an effect, but not necessarily as big as people make it out to be. Okay, 3 Mile Island. Okay, so remember, Chernobyl, we had 125 deaths and possibly eventually 4,000 who may have died early due to some radiation poisoning or other things. 3 Mile Island, no direct deaths, and it's still controversial whether that actually caused any extra cancer in people around. There's no evidence demonstrating that anyone was actually affected by the 3 Mile Island, quote, disaster, unquote. Fukushima, okay? Here's Fukushima. The problem with Fukushima is that it was tied in with a natural disaster, which was a tidal wave. The tidal wave caused part of the problem. This disaster, this mess here in this picture wasn't actually due to the nuclear blowout, but actually due to the tidal wave, which crashed on the city. So, no one died immediately in Fukushima. It's estimated that less than 2,000 people eventually died as a result of the Fukushima meltdown. Fukushima, there were some people that were working on cleaning it up. 6 people exceeded their legal lifetime limits as they were cleaning up as far as radiation is concerned. About 300 people had significant radiation dosages, and probably they say hundreds, less than 1,000, but hundreds of people are likely to get cancer. But remember that cancer is highly treatable nowadays, and a good proportion of those don't die anyway. I'm not trying to put it lightly. I am trying to say, there are a lot of people that are affected from this. Obviously, Fukushima, hundreds of thousands of people had to move from their homes, but they have been measured and checked and everything, and out of 200,000 people almost that have been checked, none of them had radiation levels over normal. Okay, so I'm not discounting the number of people that died, right? You had 125 from Chernobyl, 0 immediately in Fukushima or 3 Mile Island. But then, yes, you do have 4,000, about 2,000, maybe less, and debatable on. So we're talking about 6,000 people who died in an 80-year history of nuclear, and this is including people who got cancer, right? So, I mean, this is significant data here. Consider this. How many people have died in coal mining accidents? Just coal mining accidents in the same 80-year period since 1940. More than 6,000 people have died in coal mining accidents since 1940. So that already matches the total number of people, including the cancer patients. That already matches the number of people who have died in the nuclear power issues. Okay? Now, approximately 30,000 people die due to particle emission from coal-burning power plants every year. That means 30,000 lives every year are cut short because of inhaling the emissions, the powders that come out of the coal-burning power plant. Okay, so we're talking about 30,000 people a year. Okay, that's way above what's happening with the nuclear power. Not only that, but 44% of global greenhouse emissions come from coal, come from burning coal to create energy, which could very easily be taken away by switching to nuclear power. Okay, this is a quote from the WHO, the World Health Organization. Particulate pollution is the cause of about 16% of lung cancer deaths, 11% of chronic obstructive pulmonary disease deaths, and more than 20% of ischemic heart disease and stroke. This is dangerous stuff. But why? Why is it then such a big deal that people freak out about nuclear power? Well, it's something called risk perception. This is a psychology thing. All right? The idea of risk perception is like when you drive in a car or fly in an airplane. I want you to think just for a minute. How many people do you know of that are scared to get in the car and drive somewhere, to the store or to the airport? Probably nobody. I don't know of anybody that's frightened to get in a car because they think they're going to die in a car accident. But how many people do you know of that are scared to fly? I can guarantee you, I can guarantee you that every single one of you can think of someone who is afraid to get in an airplane and fly, or they're afraid when they're in the airplane. Okay, this is risk perception. Okay, you are, I don't know what the number is. You are like 70 times more likely to die in a car accident than you are to die in an airplane accident. In fact, you are more likely to die in a car accident driving to the airport than you are to die on your flight. Right? But nobody thinks about that because when there's an accident, when there's an airplane accident, it's huge. When there is an accident, it's fairly, well, it's pretty good chances that you're going to die if your plane crashes, right? Your car crashes, you probably won't die. But the reality is that deaths are much more common in cars, and it is much more dangerous to drive a car for the 20 miles to the airport than it is to fly the thousands of miles to your next location. Same thing with the nuclear power, right? You are much more likely to die due to something with coal burning, right? You see the numbers right here on the screen. However, when a nuclear incident happens, it's big, right? It's visible, right? You hear about it. And so there's a risk perception that says that one, nuclear power is much more dangerous than burning coal. Yet the reality is the opposite, is that more people are dying more consistently from coal than they ever have or really ever will be from nuclear power. Okay? We're going to move on from this. I think you get the point, but I like to present this in the beginning because I don't want people to be scared of it. I want people to recognize that this is actually a very safe way to create energy. But as far as really the only thing that can cause a problem in a nuclear power plant is human stupidity. And honestly, never underestimate human stupidity. However, that's why there's so many fail-safes and backup systems, and there is almost absolutely no way anything's going to go wrong there.